Section 1.7, we're talking about perimeter, circumference, and area. So these are all concepts that you've seen before, used before, and should be pretty familiar to you, but it's good to start the year with these and be able to do perimeter, circumference, area for the most basic shapes. We're going to have a whole chapter on area later in the year, so we'll go more in depth there. When starting out, let's get these basic definitions. What is perimeter of any shape, of any figure? And you should know that perimeter, and whenever you say that word perimeter, you're talking about the outside. Well, perimeter is distance around any figure, any object. So it is just one-dimensional. You're just talking about feet or inches or meters or whatever the units happen to be in, but it's the distance around a figure, measured in just units. Circumference is actually the name given to the perimeter of a specific shape, and it's the perimeter or distance around a circle is the circumference. So it is really still a perimeter. It's still a distance around. It's just a special name when it's a circle. So distance around a circle. And actually we have two, different formulas, but they are the same formula you can use for circumference of a circle. The first one that you might remember, circumference is 2 times pi times r, and r stands for the radius of a circle. And you should know that the radius of a circle goes from the center to the outside of a circle. And we also talk about the term given to, what is the term given to any chord that goes through the center of a circle, so it goes all the way across? This is called a diameter. So a radius is the same as, the diameter is the same as 2 radii put together. So another formula that you can use for circumference, instead of saying 2 times pi times a radius, is you can just do pi times diameter. And the reason these formulas are exactly the same, they both have pi being multiplied in there. Well, 2 times a radius is the same as a diameter, because a diameter is made up of 1 and 2 radii put together. So they are the same formula. You can use either or. Most of you should have a pi button on your calculators that you can use, or if you have to use a decimal approximation, you can do 3.14, but of course pi goes on forever, so it's better to be accurate and use that pi button on your calculator. So perimeter and circumference are really the same idea because they're distance around something. Circumference is just distance around a circle. Area, on the other hand, area is not a linear measurement. It's not just a straight line measurement in units. Area is the amount of space inside a figure. It's the amount of space inside a figure, inside a polygon, inside an object. So when we're talking about area, we're not just measuring it in units, not just feet or inches, but units squared. Whether it's feet squared, inches squared, meters squared, whatever it might be. Units squared, or we could say square units. Since we're talking about space inside, we're literally talking about a square that's 1 unit by 1 unit. Whether this is 1 centimeter by 1 centimeter, 1 inch by 1 inch. But we're looking at these actual physical squares and talking about square units here. So to get these area formulas for rectangle, triangle, circle, these are the shapes we're focusing on today, our most basic shapes. I'm not going to give you perimeter formulas for rectangle and triangle because they're pretty basic. You just add up the sides. Of course, a rectangle, the widths are going to be the same and the lengths are going to be the same. So the perimeter of a rectangle, you have like 2 widths plus 2 lengths. For a triangle, the 3 sides could be totally different. You're just adding those up. But let's get an area formula for a rectangle. And of course, we have 2 dimensions. We have a base and a height, or a length and a width. You can really think of it either way. But all you have to do is do base times height. If this was 3 units by 2 units, we'd have 3 times 2, or 6 square units in there. Or again, you can call length and width your 2 dimensions and multiply length and width, so either or there. For a triangle, we talk about the base of a triangle being the dimension along the bottom, and then the height of a triangle, but you have to be careful with height. You're going from a vertex at a right angle, or at a perpendicular. Of course, this mark means that you have a right angle. At a perpendicular to the base you're considering. And the area of a triangle is not just base times height, but 1/2 of base times height. Because actually if we copy and pasted this triangle and then flipped it over and rotated it, we can make sort of a parallelogram and relate it back to a rectangle, which was base times height. But it's 1/2 of that because you just copy and pasted your triangle. So know these formulas. Area of a rectangle is base times height. Area of a triangle is 1/2 base times height. Of course, perimeter is just adding up the outside. Perimeter of a circle, remember, is called circumference. We do have these two formulas for circumference, or distance around a circle, to apply, either 2 pi r pi d. And then area of a circle, we need that formula, is pi times radius squared. The way that you can tell the difference or know which one's area and which one's circumference for circles, remember that area is measured in units squared, right? So the fact that you're doing radius squared in the area formula makes sense that we're talking about area there. Alright, let's put these formulas to use here. Find the perimeter and area of a standard sheet of paper, and a regular sheet of paper is 8.5 by 11 inches. So first you say, well, what's the shape of a sheet of paper? Should be thinking a rectangle here. So I'll just put a rectangle in quick. There's about the size of a sheet of paper. I know the dimensions are 8.5 by 11 for the length and the width, or the base and the height, and I'm supposed to find perimeter and area. Obviously a lot of ways to do perimeter. We're just adding up all the sides, and if it's a rectangle we have 8.5 here, and here we have 11 here and here from both heights. One way you might think of doing this is say I'm going to do 2 times 8.5 then, since I have 8.5 in 2 places, and add 2 times 11, and 2 times 8.5 would be 17, 2 times 11 would be 22. Oops, instead of an equal sign in there, sorry. Get rid of that. So my final perimeter here, 17 plus 22 would be 39. Now remember, perimeter is a distance, and these are measured in inches, so 39 inches for perimeter. Another way, another way you might think of doing this is say, well, I'm going to do 2 times whatever 8.5 plus 11 is, because I can do these 2 dimensions and then multiply that by 2 because it happens again. And we would get the same answer here. If we did the 8.5 plus 11, we would now have 2 times 19.5, and we'd still get our 39 inches. So either way you want to think of that, you'll get perimeter. And area is actually a little bit easier. We know area of a rectangle is just base times height. So in this case, I'm going to do 8.5 times 11. 1 second here. That is 93.5. Careful with the label on area. Of course, we're talking units squared, and here we have inches. So 93.5 inches squared for area. So perimeter and area of a rectangle, example here. Let's do perimeter and area of this square in the next example. The fact that it's a square, what do you know? All the sides are congruent or the same length, so I could put 1 tick mark everywhere since it is a square. All the sides then are 5 feet in this case. My perimeter would be adding up all the sides. Well, that's 5 on each side. So really 5 times 4, perimeter would be 20. My label then, it's a distance, 20 feet around this square is my perimeter. And my area is still, I mean, a square is a rectangle, right? So base times height. Here it's 5 by 5. So area is 25. Remember that area is how much space would be inside this square. And so we have units squared or feet squared for area. Perimeter and area of a square. Alright, our circle example. Find, and I know it's a circle example because we're talking about circumference, which is our term for perimeter or distance around a circle. Find circumference and area of a circular window with a diameter 18 inches. Well, I'm going to put a little circle here. My diameter is 18 inches. Remember that diameter would be the distance all the way across that circle going through the center. Diameter is 18 inches. Now I know I'm going to need radius at some point. If the diameter is 18 inches, remember radius goes from only the center to the outside of that circle, so half of 18 or 9 inches. and then I can do my circumference and area. Remember, circumference is the distance around that circle, and I can either do 2 times pi times the radius. Remember, radius was 9. Or I can do pi times the diameter, which was 18. Now, either way, you get 18 pi, because of course 2 times the radius, or 2 times 9 is also 18. I'm going to do 18 pi in the calculator, and I'm going to use the pi button to be most exact. We'll round to, how about 2 decimal places here. Circumference is approximately 56.55. It looks like I have to round up. This was in inches. Circumference is just a distance, so this is inches as well. And area of this circle. Now, area is pi times radius squared. And here my radius is 9. Remember, radius was half of that diameter, so pi times 9 squared. In this case, be careful on your calculator that you don't hit equals to the end, because you're only squaring 9. So if you wanted to, you could do 9 squared first and get 81. We're really doing pi times 81 here. Pi times 9 squared. And again, I'm going to round to 2 decimal places. My area is about 254.47, it looks like. Area is in units squared, and my units were in inches, so inches squared for the area of that circle. So we did an example of rectangle, square, and circle here. Let's do the trickiest example of today. You can mow 71 square yards. Notice I underline it, so this is important. You can mow 71 square yards of grass in 10 minutes. About how long will it take you to mow a rectangular field that is 60 feet wide and 80 feet long? Notice we have a discrepancy here between the units. We're going to have to take care of that. Let's write down some important info here. We can mow 71 square yards of grass in 10 minutes. So I'm going to jot that down. 71 square yards, so I could write 71 yards squared in 10 minutes. I'm going to kind of write it as a fraction. I know that these are the same, right? 71 square yards is the same as 10 minutes because that's how much you can mow in those 10 minutes. Question is, how long will it take you to mow a rectangular field? Well, if it's a rectangular field, maybe I'll put a little rectangle down. Here's my rectangular field. It measures 60 feet wide, 80 feet long. I'll put those dimensions. 60 feet wide, 80 feet long. Alright, you should be asking yourself, what am I concerned with here? If I need to mow this entire field, I'm really concerned about how much space, or how many, I guess in this case, square feet does the field occupy, because I need to know the area. I need to know the space that I'm actually covering with the mower. That definitely is an area calculation that I need. I need the square feet here. And I know that for area, I just do base times height, which here is 60 times 80, or 80 times 60. The area then of this field is 4,800. Now this was in feet, and area is feet squared. And I know I'm going to have to do some conversions here. I have that there's 4,800 square feet that I'm trying to mow. I know I can mow 71 square yards in 10 minutes. I need to get 4,800 square feet into square yards first. So I'm going to take my 4,800 square feet and try to get square yards. I'm going to multiply by a conversion, and if I want square feet to cancel, then I need to put square feet on the bottom so that anything that's on top and bottom, of course, cancels. And I'm going to put square yards on top because I want that to remain. I want to know how many square yards were in this field, because that's how many, or I guess that's the units I know for how much I mow in 10 minutes. Question is, how many square feet are in a square yard? And you got to be really careful with this. You're probably thinking, I know there's 3 feet in a yard, but if you think about a square yard, there are not 3 feet in a square yard. Picture a square yard. We're looking at a square, literally. And I have to imagine, this is a square yard, right? So this is 1 yard by 1 yard. There's 1 square yard. But remember how there were 3 feet in that yard? So if I divide this yard on the bottom into the 3 feet. Here's 1 foot, and another 1 foot, and another 1 foot. But wait, isn't this square yard going this way also divided into 3 square feet? Sorry, that's really off. But 1 foot, there's my 2nd foot, there's my 3rd foot. How many square feet are in a square yard? Well, since it's 3 feet one way by 3 feet the other way, you really got to think 1 yard squared. Since it's 1 yard by 1 yard, it's 3 feet by 3 feet, and after all this, you can see there's definitely 9 square feet in 1 square yard. So 3 by 3 are actually 9 square feet in 1 square yard. So I'm really doing 4,800 divided by 9. Do this on the calculator. And I find out that there are 533.3 repeating square yards. So it's 4,800 square feet is actually 533.3 repeating square yards. Get rid of this picture here. Actually, maybe we'll just delete that. Okay. Now that I know it's 533.3 repeating square yards, I need to know how many minutes, right? How long will it take you to mow this field? One more calculation to do. I take my 533.3 repeating square yards, and I need to know how many minutes it's going to take. I'm going to multiply by another conversion. Remember how 71 square yards get done in 10 minutes? I want to know how many minutes. I want yards to cancel, so yards was on top. I'm going to put the yards squared. I'm actually going to flip the way I wrote this. I'm going to put this on bottom, so my yards squared will go away, and I'll have my minutes on top. Now there were 10 minutes taken to do 71 square yards, so I'll write it this way. Notice what I'm doing. I'm taking 533.3 repeating, multiplying by 10, because that's on top, and dividing by 71. Going to the calculator, taking that times 10 divided by 71, and I get about 75.1, I guess I'll just do 1 decimal point here, 75.1 minutes. That's how long it'll take to mow. So a lot going on in this example. We had to find the area of the field that we were mowing. It was rectangle base times height. We had to take square feet, convert to square yards. Remember, 1 yard has 3 feet, but that square yard is 3 feet by 3 feet, or 9 in this case. We found out how many square yards were in that field, and we knew that 71 square yards could be done in 10 minutes, so we multiplied by 1 more conversion. So a lot going on in that example. I have one related question. We talked about the conversion between square yards and square feet in this example, and kind of a second example here. How many square inches are in 1 square foot? Well, if we're talking square inches, which would be 1 inch by 1 inch, and I want to know how many are in 1 square foot, you know that there are 12 inches in 1 foot, but 1 square foot is 1 foot by 1 foot. And that means that first foot has 12 inches by another 12 inches in that foot in both directions, right? So 12 by 12, there's actually 1 square foot has 12 times 12, or 144 square inches. Picture that actual visual. And make sure that you're comfortable with doing those conversions between area. When you're talking about, inches to feet, feet to yards, centimeters to meters, remember that you're talking two-dimensional, so you do have to multiply. And last example here is finding or solving for an unknown variable in an area formula. You know the base of a triangle is 14 centimeters. Its area is 42 square centimeters. Find the height of the triangle. First of all, identify what you're talking about here. We're talking about a triangle. We're talking about its area. So I should write down the area formula for a triangle, since that's what I'm dealing with. And I know the area of a triangle is 1/2 of the base times the height. If you can do that much and identify the formula, you're halfway there, because now it's a matter of plugging in what you know, solving for what you don't know. And actually, I know the area of the triangle. They said the area of this triangle is 42 square centimeters. 42 goes there. So that equals 1/2 times, did I know the base? Yeah, they told me the base of the triangle is 14, so it's 1/2 times 14. And the height, I don't know. Find the height of the triangle, so just times h. That was in centimeters squared. That was in centimeters. No issue with the units. So now I know 42 equals, and I'm thinking I can just do 1/2 times 14 right away. Half of 14 is 7. Still have to multiply by h. Divide by 7. 42 divided by 7 is 6 for the height. And maybe I'll just rewrite this because I want to put units here. The base was in centimeters, area was in centimeters squared. The height, which is just, the measurement from the vertex to the base, is 6 centimeters in this case. So here we're identifying identify a formula, solve for what you don't have. All right, talking perimeter, circumference, and area today.